Hey guys, welcome to weather day 7. Today we're talking about planetary winds. So basically big picture wind patterns that happen on Earth. Just a reminder, here are the two things that I'm grading this week. You have your homework grade of the CASA Learning and you have your quiz grade of the Google form. Make sure that they are both done because I am checking them on Saturday. All right, so here is our aim. How do planetary winds flow on the Earth's surface? So just to warn you so that you can get it out now, you will need your Earth Science reference tables today, and that will be page 14. Okay, please have it out and ready to go. I will be referring to it quite a bit today. All right. Do now questions. The map below represents a portion of the air pressure field at the Earth's surface. So again, we're talking air pressure. So these are isobars, right? At which position is wind speed the slowest? So if you remember correctly, wind speed is based on pressure gradients. So how close are those isobars? So they're saying, where is it the slowest? So where are the lines spread the most? So your answer should be C. All right, C is the most spread, whereas D would probably be the fastest because that has the biggest pressure gradient. The lines are closest. Next one, a weather map of New York State shows isobars that are close together, indicating a steep pressure gradient. What is going to be most likely present? We just spoke about it. You should have your stronger winds. Next, in which diagram do the arrows best represent actual surface wind directions in the northern hemisphere of a high pressure center? All right, so surfaced wind directions of a high pressure system. Remember this, out and clockwise. So your choice should be B. Notice they are going out and they are going clockwise. Okay? This is going in, so that's wrong. This is going in, that's wrong. This is going counterclockwise, so that's wrong. Okay? All right, over here, the diagram below shows a section of the shore of Lake Ontario. Surface air pressure readings are shown for 3 of the locations. Which diagram best shows the probable wind direction for the conditions shown? All right, so you're assuming that it's day or nighttime. You can't really tell because it's a crappy image. But what they did give you are these pressure readings. So you have this, this, and this, right? So this is higher, this is higher pressure, and this is your lower pressure. Well, that's easy. Winds blow from high to low. So your answer should be C. This doesn't exist, this doesn't exist. This would be totally wrong for D. Okay, so if it's going from high to low, this one is an example of a sea breeze. Okay, because it's coming from the sea. Okay, so the Coriolis effect. We have discussed this a little bit during astronomy, but now we're coming back to it, and we're talking about why. Well, let's first define it. Basically, the Coriolis effect is when winds are deflecting, they're bending a certain direction because of the Earth's rotation, all right? Earth's rotation, make sure you know it. It's going to be a question on your quiz on Friday. Earth's rotation causes winds to deflect, okay? And a big one that you have to know is here, if this is the equator, in the northern hemisphere, they're going to bend right, and in the southern hemisphere, they're going to bend left. Okay? Now, I got 2 little clips here. One is, let's see. what we got here.
Coriolis effect. An object in motion appears to be deflected from its course, as if a force is pulling it sideways. To demonstrate this point, let's imagine a game of catch being played by two people on a merry-go-round that spins like the Earth but is flat. Without rotation, the ball appears to follow a straight path from thrower to catcher. Imagine the ball is tossed from the center to someone at the edge. With rotation, the ball still travels in a straight line in space, but because the catcher is moving, the ball misses. From the vantage point of the catcher, the ball appears to curve away. The direction of apparent motion is to the right when following the path of the ball. Now the ball is thrown the other way. Because the thrower is moving, the ball has a velocity component to the right. The motion of the ball appears deflected to the right, and the ball misses the catcher again. Let's look at a throw across the merry-go-round. Both people move with the merry-go-round.
So you guys get the basic idea, right? The whole idea is that since the Earth is rotating, the winds are going to appear that they are bending in certain directions, all right? And that's going to depend on if you're in the northern hemisphere or in the southern hemisphere. And remember what I said, everything in our solar system that you should know goes counterclockwise. So we are rotating counterclockwise. Okay, so here's the page in your reference tables. Okay, this is what we need to understand. So notice that it gives the names of the winds: southwest, northeast, southeast, northwest, and so on. Here, you got these little guys. It gives you general climates, so dry versus wet, dry, wet, dry, wet, dry. You got some of these convection currents on the outsides. All right, these are your planetary wind belts and jet streams and stuff like that. Okay, so now we're going to dissect this a little bit. So these are what you have to remember. On all those spots that said wet, you know that that is associated with low pressure. On all those places that said dry, you should associate that with high pressure, okay? The equator is hot, the poles are cold, right? Coriolis effect bends everything to the right in the northern hemisphere and to the left in the southern hemisphere. And winds get their names based on where they come from. So let's go back to that diagram now. Take a look. The first thing is, let's mark where things are hot. Okay? So warm and wet are going to be your low pressure areas, right? If it's wet, it's also going to be warm. Okay? And then you have your dry, cool area. That's going to be your high pressure systems. Okay? Fine. So far this is all review, right? We always remember this. Warm, wet, right? And then your high pressure systems are going to be your cool, dry areas. So all we did was add some temperatures to go along with the dry and wet, and the pressures to go along with the dry and wet. Now, what are those places called that are really, really wet? Those are going to be your rainforest, and places that are really dry are called deserts. All right, notice the names of the winds. All right, this is a northeast wind. Look at where it's coming from. If here's your compass and this is north, south, west, east, these winds are coming down like this. They're coming from the northeast. These are southwest winds. They're coming from the southwest. Okay? Next, a jet stream is high-speed winds, so 35 to 75 miles per hour, flow in a wave towards the east. Fine, right? So just one thing, if you've ever gone on a plane to Florida, a lot of the times the flight back to New York from Florida is a lot shorter, and that's because of the direction of the jet stream, right? Identify where the rainforests and deserts form. So we just talked about this. Those wet places are going to be where your rainforests are located, warm and wet areas close to the equator. And then those deserts are going to be your dry places. Now listen, a lot of people think hot sand cactus for deserts. Technically, a desert is just a place that doesn't get a lot of rain. Temperature doesn't matter, okay? So, how do the planetary winds shift during the winter and summer season? Take a look at this little paragraph here. In the northern hemisphere, which is where we are above the equator, the belts shift northward in the summer and southward in the winter. So all these lines are going to just shift up a little bit in the summer, and then they're going to shift down a little bit in the winter. Okay, so as far as your summary page, let's see if we could do these questions. How are winds deflected in the northern hemisphere and the southern hemisphere? So again, this is your Coriolis effect. In the north, you go to the right, and in the south, you go to the left. Okay? Describe the type of pressure that forms over the following locations. At the equator, it's wet, so that's going to be your low pressure. And at the 30s, it was dry, so that's going to be your high pressure. Using the list below, name the winds at that location. So at 20 degrees north, you're going to fall in here, right? Well, that's a northeast wind because the wind is coming from the northeast, right? And at 70 south, that was a southeast wind. Why will you find deserts located at 30 degrees north and 30 degrees south? You got your sinking cold and dry air. Those are the high pressure areas. Describe the pattern of the winds at the equator. Rising, warm, and moist air. These are your low pressure systems. Okay? All right. Also, for this one, pattern of winds, if it's low pressure, you could have also remembered this, right? In and counterclockwise. All right, more questions. So which map represents the normal location of high and low air pressure belts on the Earth? This is a pretty common question. All they're asking you for is which diagram most accurately reflects the reference table page. And your answer should be 4, right? Your low pressure is at the equator. Your high pressures are at the 30s, lows, 60s. It just alternates from there. Just remember the equator is low. Next, at which latitude do currents of dry, sinking air cause the dry conditions of Earth's major deserts? So dry, sinking, they're asking where are those high pressures? So your 30s, okay? You could have looked right up here for that, right? 3, the planetary wind and moisture belts indicate that large amounts of rainfall occur at the Earth's equator because, all right, at the equator, it's low pressure, warm, wet, loco, right? Converging, and if it's warm, it is rising. Okay, so what I want you guys to get done for today is, this was your note sheet, so you should have been good. Notes and the summary, which I just did with you, so you should be good. I want you to fill out this sheet. Okay, using your notes and using your knowledge of everything that we've discussed. Again, answer keys will be posted in the answer key folder later on. All right, have a great day. Adios. Oh, and for tomorrow, for Wednesday, I just want you to continue and do worksheet 7A. Okay, it's also in this folder. I'm not going to make a separate folder for it, but the review sheet 7A is going to be for tomorrow, Wednesday. Adios.